let's look at Guido's, right?
Yeah.
Okay, so let's see what he wants. Well, at the first line or second line, really, he makes one little mistake that is not really relevant, but the comment is wrong, and whenever the comment is wrong, then it should be a flag that something is somebody is slightly misunderstanding something. You see, the time of ASCII letters, when you had I don't know, A, B, C, and you had lower A, B, C, and you could switch from those just by calling upper and lower. Those times are gone a long time ago. Now you have Unicode, and you have such letters as these, and if you uppercase it, then you get this, and when you lowercase it, then you get this, and this is not the same, and it is not idempotent, and the world is wrong. Of course, it would be very hard if you had to really understand Unicode to do such transformations, but fortunately you don't. Python has a method on strings that really does normalize, or in Unicode parlance, folds the case fold. So you should really use this and not lower when you need to case fold, when you need to case insensitively, match or search or sort or whatever something. Because this really uses the lowercase for cased letters, and this is much more general. It uses the standard Unicode way of folding case, even for letters which don't really have a well-defined lower and uppercase.
Why then
Okay.
Python still have this lower and upper? Why don't we just replace them?
Because many times you do. Many times you need, for example, I don't know, you need to display something to the user in the uppercase. For example, title of your application is my fantastic app. Then you, for example, want to say print title upper. Of course.
Okay. But case fold will do the same, right?
When it's a matter of presenting, it's a matter of printing to the user, right? It is something meant to be consumed visually.
Okay.
And when you need programmatic access, you probably need case fold. If you want to fold the case, sometimes you don't. Sometimes you really need lower, but those are not the same, right? When you have sharp SS of German, lower. Right. It will case fold it as a standard case folding algorithm, and then when you really, for example, if you have this, you case fold it, and you get the same. So those two are really equivalent.
Okay.
And by lowering, you will not get this.
Okay.
Right. So simply two different algorithms which were the same in the time of ASCII, but in the meantime they have differed. Okay. So this should really be text case fold and word case fold. It is possible. I'm not quite sure when Python has gotten a case fold method. It's possible that when Guido made this solution, it was on February 2014. It's possible that Python didn't yet have case fold, in which case he is forgiven. But I think this was only 2 years ago. I think it was there. Okay, there is a split lines. It is nice. It is probably Guido's addition, because split is not the same as split lines. If you want to If you do this, it's not really the same as when you do this. People usually use this because they know split, but this is more sophisticated, because when you it handles new line at the end properly, because this will give you those 3 lines, and this will also give you 3 lines. Split over new line will here give you 4 lines, which is ridiculous because those are 3 lines. It has to do with the Unix versus Windows conventions. Probably people don't know much about it, but of course everybody knows about LF versus CRLF. But I'm not speaking about this. I'm speaking about on Unix. This is a line terminator, and on Windows it is a line separator. So in Windows it is usual to have files of multi-line text strings not ending in a new line. On Unix, when you open this file, it will say the file is incomplete. It is missing a new line at the end. So in Unix, it's normal, it's usual, and most editors do perceive this convention that every line must terminate with a new line. And on Windows, new line or CRLF is just a separator of lines. And the split lines really knows both those algorithms and does the correct thing. It also has one nice argument, keep ends, which you can give, and it will preserve your line endings if you really want to know which they were or something like this. Okay, so he splits and makes the lines. Okay, so here he uses an interesting algorithm to collapse space. He says remove white space, but if you really want to remove white space, oh yes, he joins with an empty string, so he really does remove all the white space. I'm not quite sure it was intended. Can I read the description? White spaces should be removed before you search. Okay, so it's okay, but of course, if you know those are only spaces, you can just say a string replace a space with an empty string. But of course, this is more general because it handles stubs, or no, it doesn't handle new lines because there are no new lines anymore. But for example, tabs or something like this. Okay, then you pad them. So you get a maximal width, and then you pad every line with spaces to width. And this is one of those examples when Guido uses Python as a newbie, because Python has a method line ljust width, which will do exactly the same thing. So if you line of text ljust, and then you see we'll add the spaces so that the whole length of it is 50, and it is much easier to read and to grasp what is going on. Ljust comes from left justify. There is also right just, which will do the obvious thing, right? And there is also a center. Okay. And then the biggest head-scratching moment that I had when reading his solutions, and after that I saw his code in many other places, and he used this idiom frequently. But for me it's weird. You see, it's a for return pattern. You make a for loop, but you don't really loop. You just take the first one and return it. Of course, Python has a built-in just for this. It has a next. So you can just say next, find it of lines words, and it will give you the same thing, except, of course, when I mentioned it to him, he said it doesn't really satisfy him because this will raise exception if you have an empty iterator, for example. This, then in next of it gives you a stop iteration, and of course for def function for answering the return answer. This will not give you stop iteration, this will just give you none, but next can also do that. So it can receive a second argument which will give the default if the iterator is exhausted. So I think there is no excuse for using this pattern, but it's his language. Okay, and how does he actually find it? Well, he determines the dimensions of lines. He goes over them with indices, of course, using enumerate. It is good. And when he finds a first character, then he goes slicing. He slices the line and sees whether it is word. And if it is, then he yields a combination corresponding to horizontal finding, and else should probably use Aleph here, because of course he only wants one solution, but of course this find it can be used more generally. It can be used to find all appearances, and of course then he slices otherwise, not really slices, but just makes a for loop. Okay, this is nice. He uses for else, just to say if all of those are the same, if lines row plus I of column is equal to word of I for all I, then you yield this, and otherwise you break, and this else doesn't execute. It's a nice way to avoid standard Boolean variables, which people use in Pascal, for example. If you want to say stopped is false, then if you blah 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 for loop, if something stopped is true, then you break, and after that you have if stopped, or if not stopped, really. This pattern is this pattern is really frequent when you're coding some more complicated algorithms, and Python has a nice way of saying this. You just say for whatever, if something, you just break, and else you do something if you didn't break. It's much easier to read, and when you know about this idiom, it is really easy to understand. Much easier than this, especially when you have more loops and more Boolean variables. This really shines. One frequent use case is this: when you have a for and a while. When you want to say, for example, for whatever, if something break, else you break from here. In this case, it's probably nicer to write it in one line. What is this? This is execute this inner loop while the outer one is changing, while the outer one is doing something. For example, if you need a fixed point, you start with some objects in the iteration, and when you find another object, you append it. whatever you found, and then you restart your loop. And then you restart your loop while you are finding the objects. Whenever you survive all the for loop without finding the object, then you just break the outer loop. So this modifies this iteration while it changes. When it doesn't change, when it stops changing, then it breaks the while loop. I have used that pattern in one solution, but I couldn't quite remember which one. Okay, and of course it is a nice readable solution, but there are few words and few things that I thought only a Python newbie would do. So I really called him for it, and he said that a very nice sentence. I have lots of power tools in my tool shed, but I still fix most things around the house with just a screwdriver if I can. So he kind of prefers those simple tools over some more advanced ones. And it's a nice thing to do if you really can, and Guido surely can wear two different hats on his head at different times. So when he's designing the language, he really understands deeply the needs of people who want to write Python. And when he writes Python, he just wants to use a screwdriver. It's very very fascinating character trait that not many programmers have. For usually when we are programming, we want to read the code of others as they were meant to be read exclusively by us. But Guido can really see the wider picture, and it is the biggest reason why Python is so powerful.